And now we have a talk from Gobe Hobona, Director of Product Management Standards at Open Geospatial Consortium. We are in the Open Standard track, and we will love hearing about specially enabling web APIs through OGC Standards. Hello, Gobe. How are you?
Hello. Hi, Mary. All right. Thanks for this opportunity to talk to you about OGC standards.
Yeah, we need more standards. We need more special data. And so we need more of you. Thank you very much for being there with us. The stage is yours for 20 minutes.
All right. Thank you. Hi, everyone. Bonjour. So my name is Gobe Hobona, and I work for the Open Geospatial Consortium. I'm going to talk to you about spatially enabling web APIs through OGC standards. First, an overview of who the OGC are. The OGC is an international consortium with more than 500 member organizations from the government, private, and academic sectors. These organizations come together to develop geospatial standards that improve the ability to access and make use of location-referenced information. Our vision is to build the future of location with community and technology for the good of society. And we do this by making location information more findable, accessible, interoperable, and reusable. Now, why are we interested in location information? Well, it's often said that more than 80% of data that is needed to support decision-making has got a location reference in it. If you consider that most data that is used to support decision-making either has a place name, a postcode, or a zip code, or geographic coordinates, you can easily see how this 80% estimate actually comes to being. So location information is everywhere, whether you've got a mobile phone, or perhaps you make use of the weather forecast every morning, or you take photos wherever you go, or perhaps you drive a car that has got a sat-nav. Location information is everywhere. So the OGC has developed a 5-step process to spatially enable any web API. First, you identify the type of location-referenced information that you would like to publish or access. You then identify the relevant OGC API standard at the ogcapi.ogc.org website. You then familiarize yourself with the requirements documented in the relevant OGC API standard. You then use the Open API definition document and schemas from the OGC API standard that you've identified to help build your implementation. Finally, you test your implementation for compliance to the relevant OGC API standard. Now, what is an OGC standard? Well, an OGC standard is a document established by consensus and approved by the OGC membership that provides rules and guidelines aimed at the optimum degree of interoperability in a given context. To develop these standards, we take into consideration a whole variety of technology trends and market trends, as well as requirements from the OGC membership and the wider information technology community. We hold 4 member meetings every year, and what you can see on this slide is a photo taken at a member meeting back in March 2018. So why are we developing OGC API standards, and why should you be interested in OGC API standards? Well, APIs are a very effective and very popular enabler of rapid software development. And what we've seen as we've reviewed quite a number of APIs implemented across the web, we found variations of how those APIs represent location data. And in some cases, that variation is not interoperable, is not implemented across different systems. And as a result, the variation in how the APIs implement location support can, to an extent, degrade interoperability. So the OGC has embarked on a program to develop OGC API standards that will make it possible and for different solutions to exchange location referenced information, making it possible for different vendors and solution providers to integrate the products and to enable those products to share location reference information in a consistent way without losing any information. To develop these OGC API standards, we've applied a series of principles. First, we've applied the spatial data on the web best practices. These are best practices that were developed by the OGC and the World Wide Web Consortium, also known as the W3C. OGC API standards also implement the Open API specification to help the API implementations describes the resources that they offer. And we've designed these standards to be as implementer friendly as possible. We've focused on the developer experience to make it possible for developers to easily pick up a standard and implement support for that particular standard in an efficient and effective way. The standards have been developed as modular building blocks to make it possible to integrate the implementations of different OGC API standards into solutions that address a variety of needs. And then finally, what we've done is to ensure that the standards are developed out in the public. So we're using public GitHub repositories, and we're encouraging early implementations to ensure that the standards can be validated and refined prior to being published. So what are those OGC API standards? On this slide, we've got an overview of approved and candidate OGC API standards. The ones with the green borders around them have been approved. The one with the dashed green border has been approved, but will be published later on this month. So starting from the top left, we've got OGC API Discrete Global Grid Systems, which specifies an interface for accessing resources that have been organized according to discrete global grid systems, also known as DGGS. These are partitions of space or partitions of the Earth into different levels of detail. And then we've got OGC API Records, which specifies an interface for accessing catalogs of metadata. OGC API Maps, which specifies an interface for accessing rendered electronic maps and charts. OGC API Styles, which specifies an interface for accessing portrayal information such as styles and symbology. OGC API Tiles, which specifies an interface for accessing tiled resources such as map tiles and vector tiles. OGC API Common, which specifies the foundation building blocks on which all the other OGC API standards are built. OGC API Routes, which specifies an interface for accessing routing information such as is used for transportation. And then OGC API Environmental Data Retrieval, which specifies an interface for accessing spatial temporal environmental data and querying such data using a variety of geometries such as trajectories, cubes, and so on. And then OGC API Features, which specifies an interface for accessing vector feature data, the type of feature data that you can create by simply publishing spreadsheets, for instance, that have got columns with geographic coordinates or columns with zip codes or postcodes, or simply spreadsheets with place names on them. Those are examples of vector data, including shape files or geopackage files, which are SQLite databases offering vector data. So all of those types of data formats and data sources can be published through implementations of OGC API features. And then we have OGC API processes, which specifies an interface for accessing implementations of algorithms that are accessible as executable processes. And then OGC API coverages, which specifies an interface for accessing coverage data such as satellite imagery or even some forms of meteorological data. We are continuing to develop the suite, so in the future you will see additional candidate OGC API standards introduced as well. So to support developers, we have developed executable test suites that are accessible from the OGC Validator. This is a compliance testing tool that makes it possible for products to be tested to determine whether or not they comply with a particular standard. Implementers of those products, upon running their products through the compliance testing tool, they can then apply for certification of their products as OGC compliant. And what you can see on this slide is a screenshot of in fact, it's a sample OGC compliance badge. For more information about compliance testing and certification, please feel free to send an email to the address shown on this slide. Right, now what can you expect as an API developer? Well, as an API developer, you can expect a variety of resources on the ogcapi.ogc.org website. We've put together quite a number of resources on that website to help developers implement OGC API standards. So you'll find links to the various GitHub repositories, as well as overviews of the various OGC API standards. You'll also find links to previous and future OGC API code sprints and hackathons. You'll find videos of demonstrations from previous initiatives, as well as several other documents to help you get started with OGC API standards. As I mentioned, we have GitHub repositories offering quite a number of resources to help implementers. Also on those GitHub resources are issues boards with issues that have been logged in the past, as well as questions. These are an extremely good resource if you have questions about OGC API standards and perhaps you're implementing one and need some form of clarification. Our working groups are always ready and willing to respond to a question to help the community adopt these standards. And we also publish open API definition documents. So each OGC API standard is published as an actual document, so a Word PDF document, HTML document, but also an open API definition document to accompany the actual standards document. We're currently using OpenAPI version 3.0.2, but we'll be looking at advancing to OpenAPI version 3.1 in the near future. So let's look at 3 examples of OGC API standards. We'll start off with OGC API features. On this slide are the key resources offered by the OGC API features standard. Remember that this standard makes it possible to publish vector feature data. Examples of vector feature data are those that you'll find in files such as shapefiles or spreadsheets, or in several other forms of data sources. So OGC API features offers resources that include a landing page, a conformance declaration, a collections resource or feature collections resource, and also access to individual features. The landing page effectively is you can call it the shop window. It's the entry point into that API. And then the conformance declaration tells you which capabilities that particular implementation of OGC API features actually offers. And the feature collections resource lists the data sets that are available from that particular or through that particular API. And then the features resources allows you to actually access individual feature data, but also to query the data sets as well. Now let's look at OGC API processes. OGC API processes, remember this offers an approach. It specifies an interface for accessing implementations of algorithms that are executable as processes. And the standard offers a landing page resource, a conformance declaration resource, a process list, as well as process execution, as well as resources for monitoring jobs that have been invoked or those that have been completed. And you can see examples, you can see the paths for accessing those resources on the slide as well. OGC API Environmental Data Retrieval also offers a landing page, a conformance declaration, as well as collections resources. So you can see that we maintain the same pattern across all of these standards, ensuring that there's a landing page, a conformance declaration, as well as collections or lists of data resources or processes that are available from that particular API implementation. Now, we've seen various deployments of implementations of OGC API standards. The standards have been designed as building blocks, so many of the implementations integrate two or more OGC APIs. Some of them actually just simply implement one OGC API standard and deploy them as microservices. But we have seen a variety of deployments. The standards have been designed to allow to enable integration by bringing the various building blocks together to build solutions that address a variety of needs. So let's look at a number of case studies. So a case study, an example case study for OGC API features is the data publishing site offered by the British Geological Survey. The British Geological Survey publishes its geological data through an implementation of OGC API features, and you can actually access it at the URL shown on this slide. So on the left-hand side of this slide, you can see some of, well, an HTML rendering of some of the key resources. So this is actually the landing page being rendered as HTML. So with the API allows for the landing page to be accessed as JSON as well underneath. And that is, there's a link on that page as well. So you can access an implementation of OGC API features in either HTML or JSON or other encodings. Another case study is that of an implementation by a company called CubeWorks, which has implemented an analytical processing capability for RadarSat satellite imagery using the OGC API processes standard. Now, what this implementation does is that it pulls satellite imagery in real time from the RadarSat mission, and it analyzes the satellite imagery and identifies the location of vessels. One example application of this is, for instance, if vessels have switched off the automatic identification system or AIS system devices, this solution, this OGC API processes solution allows for satellite imagery to be processed in real time and to identify and locate those vessels. Another example case study is that of OGC API environmental data retrieval implementations at the US National Weather Service, where they've implemented a weather forecasting capability, a client application that sits on top of an OGC API EDR implementation that acts as an interface onto the weather forecasting capability. And that's a screenshot of that client you can see on this screenshot as well. So to help us develop these standards, we run various innovation initiatives such as testbeds, pilots, plugfests, code sprints, and research projects. And we have just recently completed testbed 17. So the testbeds are an annual initiative, and this is the 17th phase of that. So basically, we've been running for close to 20 years, running the testbed initiative for close to 20 years. Testbed 17, which ran this year, covered a variety of topics, and you can see those topics on this slide. So aviation, sensor integration, data-centric security, data queues, and so on. We also run code sprints, as I mentioned. Our next code sprint will be March 1st to the 3rd. It will be a joint code sprint between OGC, the Open Source Geospatial Foundation, and the Apache Software Foundation. So it will be a joint OGC, OSGeo, and ASF code sprint. It will actually be the second joint code sprint we've held with our partners. Registration will be free, participation will be free. We're currently looking at March 1st to the 3rd, but that's a tentative date. And we are aiming to announce the actual date by the end of next week. So what can you expect as an end user? Well, as an end user, you can expect a variety of client applications. For example, we've seen 3D visualization applications that make use of OGC API tiles. We've seen discrete global grid systems that make use of OGC API DGGS. We've seen data science and machine learning applications that make use of OGC API coverages, including running the analysis from Jupyter notebooks. And we've also seen augmented reality applications that make use of OGC API tiles. So how can you also enable your web API? Well, as I mentioned earlier, the OGC has a 5-step process, and you've seen examples of how that process is applied. Step 1 is to identify the type of location reference information that you'd like to publish. Step 2 is to identify the relevant OGC API standard. Step 3 is to familiarize yourself with the requirements documented in the standard. Step 4, you use the Open API definition of that OGC API standard to help build your implementation. And then finally, you test your implementation for compliance to the relevant OGC API standard. So in summary, OGC API standards are becoming a key requirement for web APIs offering location-referenced information. We are seeing early impact across government, private, and academic sectors, literally across the globe. So we're recommending that organizations spatially enable their web APIs through OGC API standards to ensure that their data is findable, accessible, interoperable, and reusable. And that's it. Thank you for listening.
Thank you, Gobe. Thank you very much. We just reached the time 50 for your presentation. But me, just a question. Why, I would just ask for all the potential contributors or people who wants to join, why it's so important to have a standard for geospatial data? Like, why, let's say, what would be possible if we have a standard coming?
Yeah, so, well, first and foremost, I'll say more than 80% of decision-making relies on location. You know, whether it's where to position COVID vaccination centers, or whether it's to understand how, you know, the pandemic is spreading at a local or even global level. And also for other applications, location reference information is so critical to society that it's important that applications that handle such location are able to communicate consistently and correctly as well. If you get location wrong, it's very possible that you can get decisions all wrong as well. So that's why standards are important to ensure that all of these applications that we're building across the IT industry can communicate location correctly and consistently.
Yeah, that makes total sense. And you know the famous saying, location, 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 right? So it happens. It's always the case. So as a community, let's invest into the standard. So we'll spend a little bit of time building the standard, but then after that, the innovation will be at lot lower cost, because we will not have this interoperability cost or this the time to like plug things together. We'll just concentrate on the value proposition. Thank you very much, Gobe, to present that. We would love to invite you again in other conferences in other area of the world. Thank you.